So with this question here, we've got circle theorem certainly involved, and also don't be surprised to have trigonometry involved as well here. Okay, we might see a bit of trigonometry here. So they've given us certain things. They've told us that angle there. They've told us this here, and they want us to write down the size of angle BDC. Okay, BDC. Now let's have a look at where BDC is. So BDC, B to D to C, where the roof is above, so the angle in the middle there, joining B to D, D to C, so D in the middle, that angle they want. Quite simply, I can say, look, angle BDC is equal to 28 degrees. I know it's not on the scale, but it kind of looks like it. Okay, not that you should go by that. Okay, but the theorem is, right, angles. And we need to give a reason, because this is one of those OCW questions, right? Okay, here, so they want you to communicate and explain your workings correctly. So you need to explain, well, why is it 28? And you need to say, look, because angles in the same segment are equal in value, okay? That's the circle theorem in the same segment. Okay, and if you remember, they subtend from the same 2 points. So this angle here, okay, is created from these two lines, which subtend from C, and that subtends from B. And you say the same here, look. The angle there is created because it subtends from C and B, from the same 2 points. And in the same segment, so they're equal. Now, we then said, hence calculate the length of BD. BD, now BD is this here, right? This here. They want this diameter, don't they? Okay. What's good is I know this length here to be 4.7. Okay, so we know that's 4.7. We want this length. Now, when we've got angles involved and lengths, and then they're asking for another length, maybe we've got to be thinking about trigonometry, SOHCAHTOA. Okay, and remember, SOHCAHTOA can only be used on a right angle triangle. Have I got a right angle triangle here? Well, yes, we have, because if you think about it, that there's a right angle. Okay. So that there we can say, let's just get our notation right here, what we call that angle, BCD, yeah? Those are the two sides here, so BC, CD. So we say, look, angle BCD, and put the roof where the angle is 90 degrees. And the reason is because angle in a semicircle is 90 degrees, or a right angle. That's another circle theorem, okay? You know, if you cover up there, you've got half the circle up here, half the circle, and when you've got the diameter there involved, that's going to be 90 degrees where it touches the circle, okay? So we've got that. Now we've simply got SOHCAHTOA, right? We've got SOHCAHTOA, and with SOHCAHTOA, if you remember, your right angle here, so opposite the right angle is the hypotenuse, okay? Right, just ignore this line here, opposite the right angle is the hypotenuse. There's your angle opposite there, and then of course you've got your adjacent here. You might find it helpful, I mean maybe I'll do this, is to redraw the triangle down here. So because you've got a few lines there maybe putting you off, okay? And it's a case of seeing, well, there's my D, there's my C, there's my B, that's my right angle, like I've got up here. Okay, there's my diameter with a centre there, and this is angle 28 degrees. And I want to find BD. I know this is 4.7. So as I said, we've labelled this, that's hypotenuse, because it's the longer side, and it's opposite the right angle. Opposite there, the angle, 28, and then of course you've got your adjacent there next to the angles. So what we do then is SOHCAHTOA. Okay, now we've got O, we've got the opposite already given to us. We want to find H, don't we? We want to find this diameter here, BD. So O and H will be sine, of course. So sine of the angle, 28, equals, go in that order, opposite over hypotenuse. So 4.7 over the hypotenuse. Okay, so go in that order, sine equals opposite 4.7 over hypotenuse. Now, whatever's on the bottom here, you take up. Okay, so I've got H on the bottom here, let's take it up. So H times, because you're dividing, of course, take it up, you times. Sine 28 equals 4.7. And to get H on its own, I need to get rid of this sine. So because I'm timesing by sine, take it over and divide by sine. Okay, so you get that. Let's get my calculator, and then you can do this in one go. If you want to use the fraction button, it's up to you. 4.7, or you could just do 4.7 divide by sine 28, and we get our answer, and that would be 10 point. And I will put it, even though it's 10.0, it looks pretty much 10. I am going to put 10.0 to show one decimal place, like they give me this to be one decimal place. So just to make sure you finish off, because this is an OCW, just be clear, you say that, you know, therefore BD, isn't it? That's what they wanted it as, BD. We've called it H for hypotenuse, but BD, we need to call it that. And we're done.